Betelgeuse, located at a distance of approximately 642.5 light years from our planet, stands out as one of the most fascinating stars we can observe in the Earth's sky. Recognized as the shoulder of the constellation Orion, the star has experienced an intriguing existence since its formation. The celestial body has been notable for its distinctive outward activity. One of the most notable aspects has been the variation in its luminosity, presenting moments when its brightness decreases and then recovers over the course of several days. This phenomenon has been observed since Betelgeuse was discovered. However, in recent times, the behavior of its surface has shown an increasingly unpredictable trend. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, hit the like button, and activate the notification bell. There has been much speculation about the behavior of this star and its possible future development. There is still the possibility that at some point it will undergo a transformation into a supernova, an idea that has been the subject of discussion. However, successive nuclear explosions of even greater magnitude are occurring at each point in time. These events will release such a colossal amount of radiation that it would be enough to annihilate our planet in a matter of seconds. Of course, these events manifest themselves in all regions of the universe, scattered over distances of hundreds, thousands, and even millions of kilometers from our own world. They are far enough away that their consequences do not impact us directly. The only source of cosmic radiation that directly affects our planet is our own sun, although even this solar radiation is filtered by the protective ozone layer. Now, why does this have to do with Betelgeuse? As mentioned above, Betelgeuse is a star more than 600 light years away. At present, it has accumulated several million years of existence, and its reddish color derived from the relatively low temperature of its surface, only about 3000 degrees Kelvin. The star, also known as Alpha Orionis, due to its red supergiant status, is in the final phase of its life cycle. As is known, larger stars consume their fuel supply at a faster rate. Betelgeuse long ago used up all this hydrogen as it grew in size. Astronomers postulate that the star will experience a Type II supernova in its evolutionary process, which could result in the formation of a neutron star. However, considering the levels of oxygen and neon present, the possibility of evolving into a white dwarf cannot be ruled out. The main challenge associated with an eventual explosion of Betelgeuse involves several aspects. Primarily, it is essential to take into account the distance that separates us from this star. This concerns not only the range of the explosion, whose range has not yet been pinpointed with complete certainty in terms of its impact on Earth, but also how long it might take us to detect whether the star is on course to explode or not. Put more simply, it is very likely that Betelgeuse exploded several decades ago, but we are not yet aware of it. This is because the light emanating from the star must travel for 642.5 light years to reach us so that it can be studied here on Earth. As I mentioned previously, we have talked about the possibility of Betelgeuse evolving into a supernova. This is a natural process that all stars follow when they are in the final phase of their lives. Supernovae are the high point in the life of a star, where its size and temperature grow exponentially before exploding into a stunning release of light and energy. According to various investigations, it is estimated that the glow from the explosion could be intense enough to illuminate an entire galaxy, even if only for a short period of time. During the Betelgeuse outburst, it is estimated that the supernova would release even more energy than our Sun could generate in its entire lifetime. Therefore, supernovae represent the largest explosions occurring in space. An illustrative example is the explosion of the RCW86 nebula, which was recorded by Chinese astronomers in the year 1054. It was so powerful that it could be seen clearly during the daytime. So we wonder, what would be the possible implications of a Betelgeuse explosion for our planet. Initially, at the onset of its transformation, it is plausible that the release of energy would be intense enough to have some degree of impact on power grids, either in certain specific areas or even globally. This could manifest itself into a form similar to an electromagnetic explosion, EMP, also known as an electromagnetic pulse. In addition, the emission of radiation could trigger geomagnetic storms, which will have the potential to cause additional damage to power grids, generate visual phenomena in the atmosphere, and disrupt various satellites, particularly GPS systems. Naturally, the steady-state evolution of Betelgeuse has been a valuable resource for scientists in the contemporary era. This star has become the most promising study subject for examining the evolution and behavior of stars in their late stages, given that it is the closest star of its type to Earth and a candidate to go supernova. Between 2019 and 2021, the star experienced dimming after releasing a considerable cloud of debris following an explosion. This incident came to great puzzlement among scientists, who finally found an answer in 2021. They were able to establish that the mass ejected by the star was traveling at speeds in excess of 200,000 miles per hour, equivalent to about 320,000 kilometers per second. Despite expectations that this debris would travel significant distances, the coldness of condensed space and reduced the velocity of these particles in a relatively short period, which also sheds light on how the eventual explosion of Betelgeuse could affect us. Once the red supergiant begins its supernova process, Betelgeuse will glow with an intensity of about 9 times greater than the full moon, in an event that can be observed for an approximate period of time from Earth. In preparation for the eventual explosion, researchers will strive to detect a large number of neutrinos coming from the direction of Betelgeuse. In addition, once the process is completed, it is presumed that although the brightness of the explosion will fade with time, it will still be observable in the sky for several years. Although there is a possibility that the explosion may have some impact on our planet's power grids, as I mentioned above, these odds are quite slim. What is certain is that the explosion of this red supergiant will generate a remarkable stir in social and cultural aspects, especially for those who are not more identified with these astronomical phenomena. It is a common tendency in society to react with fear and amazement to physical and atmospheric events that may be disconcerting. Therefore, it is of great importance to cultivate knowledge as a fundamental virtue. This marks the end of our presentation for today. We encourage you to share your thoughts in the comment section. Also, we remind you to express your appreciation if the content has pleased you and share it with your friends in order to expand their horizons of knowledge. Don't forget to subscribe to the channel, hit the like button, and turn on the notifications to keep up to date with upcoming releases, which promise to be even more fascinating than today's video. Thank you so much for watching the video, and I'll see you in the next one.